So, the answers to the proportionality questions. This is a topic that's always been a real puzzle to me because people find it really difficult, and one day I'll understand why, but it is seen that way. So, first of all, we've got to translate. We've got to translate this into sort of mathematical language. So, we've only got some relationships. We've only got a few. So, this is saying that P. Let's start again. Use the bigger one. Right, P is, and this is the proportionality sign, so that's that bit, and inversely means 1 over. So that means 1 over, and that means that. So P is inversely proportional to D squared. And that's a proportionality relationship, and we can always then move on to an equation that links the two, P and D. So P equals some number divided by D squared. And there's several ways to get the number here. One way is to rearrange this. We could have, so that means we multiply d squared up, so p times d squared is equal to k. And now I can work out what k is, because every single time you see one of these questions, they will give you a pair of values. Every single time. So k is equal to p, which is 10,000 in this case, and that's times d squared, so 0.4 squared. And that gives me 2 times 0.4 squared on the calculator, 1600. And what that means is that the equation linking P and D is this: P equals 1600 over D squared. So what I've done is I've taken this thing here and I've stuck K in it to get my equation. That's not my final answer though. This helps me get my answer. My final answer, it says find the value of P when D equals 0.8. So it's very trivial. P is equal to 1600 divided by 0.8 squared. So 1600 divided by 0.8 squared is equal to 2,500. And that's the answer. Okay, next question. So, same as before, we've got directly proportional to this time. So that means that M is, and we've got directly proportional to, looks like this, L cubed. There's no 1 over, so this just means that it's just a straight relationship. So M equals some number times L cubed. And if we want to know what that number is, we rearrange it, so M divided by L cubed is going to give us that number. And every single time you see one of these questions, they will give you a pair of values, which is what I'm about to use. So M is 160, and I'm dividing it by 2 cubed, which will give me 160 divided by 8, which is 20. So now I can put my bits of information together. I can put my my formula here and my value of M together to get, sorry, not my value of M, my value of K. M is equal to K, which is 20, times L cubed. And that's the formula. And the question says find the value of M when L equals 3. So M is equal to 20 times 3 cubed, which is 20 times 27, isn't it? 3 cubed, which is 540. Normally on a calculator paper, these. Question 3. You've probably got the idea now, so if you've been a bit stuck and you want to have a go, now you might have a quick pause and try it before I do it. So I'm going to translate this. So here we are, inversely proportional. So Q is inversely, that means 1 over, to the square of T. That means you take T and you square it. And that's not the formula, that's the sort of proportionality relationship, so I'm going to put my K in now, so that means Q equals some number divided by T squared. and that will have got me some of these marks. I now need to find out what the number is, and surprise, surprise, there's a pair of values given. So let's rearrange it to work out what k is. So k is equal to q times t squared. I've just multiplied the t squared on both sides. So k is equal to q, which is 8.5, times t squared, so that's 4 squared, which gives 8.5 times 4 squared, 136. And now I can write my formula down. Q equals 136 divided by t squared. All I've done is I've taken my formula and my value of k and stuck them together. And now the second part says calculate the value of q when t equals 5. So I'm going to use my formula. So q equals 136 divided by 5 squared. So 136 divided by 5 squared is 5.44. So here we are. The challenge question. Maybe it's a challenge, maybe not. This is, again, it's the same stuff. So please don't be intimidated by these things. Realise that there's a pattern that you can learn. And often when people learn how to follow a pattern, then they start to understand why it works later on. Or they think of questions to ask. So here we've got t, and it's proportional to, so there's no inverse, notice. So t is proportional to, and then we've got the square root of the surface area A. So t is proportional to the square root of A, which means that t equals some number times the square root of A. And sure enough, there's the pair of values, there they are. So we'll rearrange this, so I'm going to have to get k on it, so I'm going to have to divide by the square root of k. So k is equal to t divided by the square root of A, and t is 40, and it's the square root of 100. I think we can do this without a calculator, can't we? Square root of 100 is 10, so it's 4. So that means the formula is, and I'm using, remember, this thing here and this thing here. So my formula is t equals 4 times the square root of A. And you might leave your time signs in if you feel more confident like that. Now, find the value of t when A equals 60. Really straightforward. T equals 4 times the square root of A, but hang on, A was 60. And I put that into my calculator, so 4 times the square root of 60, and that gives me 30.98386677. And a good practice here is when you've got a number like this in your calculator, write lots of it down. You're showing the examiners, if assuming you're right, a good load of your accuracy, and then look for whether they want you to round it. And of course here they do, 3 significant figures. So you start at the front for significant figures, always start on the biggest bit, and you go 1, 2, 3, and that's where we're going to chop the number off. Now the 8 there means the 9's going to go up, and if the 9 goes up it's going to go up to a 1 there, so it's 31.0. And it's important we put the 0.0 here because they've asked for 3 significant figures, so you should get the first 3 bits, 1, 2, 3, even if one of them's a 0. And that's the end.